The sun is incredibly bright. It lights up our world. So why is space still dark? Imagine standing in space, only 150 million kilometers from the brightest object in our solar system. The sun releases an unimaginable amount of energy every second. Its light races across the vacuum at nearly 300,000 kilometers per second, reaching every planet, every moon, and even the distant worlds beyond Neptune. From Earth, the sun dominates our sky. It turns day into daylight, casts sharp shadows, and makes even the smallest details visible. It feels powerful enough to illuminate everything around it. So here's the mystery. If sunlight fills the solar system, why doesn't space look bright? Why, even just beyond Earth's atmosphere, does the sky suddenly become pitch black? Astronauts aboard the International Space Station orbit Earth, bathed in brilliant sunlight. Their spacecraft shines intensely, our planet glows beneath them, and the sun appears almost blinding. Yet surrounding all of it, there is only darkness. No glowing sky. No bright blue horizon stretching into space. Just an endless black backdrop filled with distant stars. At first, it seems to make no sense. Many people assume cameras are responsible for this effect. Others believe space is simply too empty to reflect light, or that the darkness is some kind of optical illusion. But none of those explanations tell the real story. The truth is far more fascinating because it challenges one of the most basic assumptions we make about light. We've been taught that light illuminates everything it touches. In reality, that's not quite how light works. To understand why the universe remains dark, even beside a star as powerful as the sun, we first need to answer a much simpler question. What does it actually mean for light to illuminate something? The answer may surprise you. The sun does fill space with light. In fact, at this very moment, trillions upon trillions of photons are streaming away from the sun in every direction. They travel across billions of kilometers, carrying energy through the solar system and far beyond. So if light is everywhere, why don't we see it? The answer lies in a simple fact that most of us never think about. Light is invisible while it is traveling. You cannot see a beam of light simply because it exists. You only see light when it reaches your eyes after interacting with something else. Think about a flashlight at night. If you shine it through perfectly clean air, the beam is almost impossible to see. But introduce fog, smoke, or dust, and suddenly the entire beam becomes visible. The flashlight didn't become brighter. The particles in the air simply scattered some of its light toward your eyes. Space is different. The vacuum between the sun and Earth is almost completely empty. There are so few particles that sunlight has almost nothing to bounce off. As a result, the light continues its incredible journey through space without revealing its path. It remains invisible until it strikes a planet, a moon, a spacecraft, or ultimately, your eyes. This is why Earth glows brilliantly in sunlight, while the vast emptiness surrounding it remains perfectly black. The sun has never stopped illuminating the solar system. The light has always been there. The real mystery is that in the vacuum of space, there is almost nothing to reveal it. If space is filled with sunlight, then why does the sky above us look completely different? The answer isn't the sun, it's our atmosphere. Earth is wrapped in a thin blanket of gases made up of billions upon billions of tiny molecules. As sunlight enters the atmosphere, it collides with these particles and changes direction. This process is called scattering. Not all colors of light scatter equally. Blue light has a much shorter wavelength than red light, making it far more likely to bounce off the molecules in our atmosphere. Instead of traveling in a straight line, blue light is scattered in every direction. That scattered light reaches your eyes no matter where you look. The result is the beautiful blue sky we see every day. At sunrise and sunset, sunlight must travel through much more of the atmosphere before reaching us. Along the way, most of the blue light is scattered away, allowing the longer red and orange wavelengths to dominate the sky. But what happens when you leave Earth's atmosphere? As astronauts climb higher, the air becomes thinner and thinner. There are fewer molecules to scatter sunlight, and the familiar blue sky begins to fade. Eventually, the atmosphere becomes so thin that almost no scattering occurs at all. The blue disappears, the stars emerge, and the sky turns completely black. The sun hasn't changed. Its light is just as powerful as it was at the surface. The only thing that's missing is the atmosphere that made that invisible light visible in the first place. This simple difference explains why Earth enjoys bright blue skies, while the vast emptiness of space remains wrapped in darkness. At this point, the mystery begins to unfold. Light doesn't need air to travel. Unlike sound, which requires molecules to carry its vibrations, light can move through the vacuum of space completely on its own. Once a photon leaves the surface of the sun, it begins an extraordinary journey across the solar system at the speed of light, nearly 300,000 kilometers every second. But here's the remarkable part. That photon remains invisible for almost its entire journey. Imagine throwing a perfectly transparent glass marble across an empty room. You wouldn't see it flying through the air unless it reflected light toward your eyes. In many ways, photons behave similarly. They don't create glowing paths behind them, nor do they paint the darkness around them with visible light. Instead, they silently race through space until something interrupts their path. A planet, a moon, a spacecraft, a cloud of gas, or your own eyes. Only then does their journey become visible. This is why Earth appears brilliantly illuminated from orbit. Sunlight strikes the planet's surface, reflects in countless directions, and some of those reflected photons eventually reach a camera or an astronaut's eyes. The same is true for the moon. It doesn't produce its own light. Every glowing landscape, every bright crater, and every lunar sunrise exists because sunlight reflects off its dusty surface. The empty space between these worlds, however, offers almost nothing for light to interact with. There are no dense clouds of air, no endless fields of particles, no invisible screen waiting to catch the sun's rays. So even though trillions of photons are rushing through that region every second, almost none are redirected toward your eyes. The result is one of the greatest visual illusions in nature. Space appears empty of light, when in reality it is flooded with it. The darkness surrounding our planet isn't evidence that sunlight is absent. It's evidence that the light is passing silently through one of the emptiest environments in the universe, revealing itself only when it finally finds something to illuminate. If sunlight remains invisible as it travels through space, another question naturally follows. Why can we see the stars? After all, they're surrounded by the same darkness. The answer is that stars don't illuminate space around them in the way we often imagine. Instead, they produce their own light. Every star is a gigantic sphere of hot plasma, powered by nuclear fusion deep within its core. Every second, it releases an enormous number of photons in every direction. Those photons begin incredible journeys across the universe, traveling for years, centuries, or even millions of years before reaching another world. Throughout that entire journey, the light remains almost completely invisible. Only when those photons finally enter your eyes, or strike a camera or telescope, does the star become visible. You're not seeing the empty space between you and the star. You're seeing the destination of countless photons that have traveled unimaginable distances. This is why stars appear as tiny points of light instead of illuminating the entire sky. They are incredibly bright, but they are also incredibly far away. Their light reaches us directly, while the vast vacuum between us remains almost perfectly transparent. Earth offers a perfect comparison. During the day, the stars don't disappear. They're still shining exactly as they do at night. The reason we can't see them is that our atmosphere scatters sunlight, filling the sky with blue light that overwhelms the faint glow of distant stars. Once that atmosphere is gone, the illusion disappears. This is why astronauts in orbit can see a black sky even while the sun is shining nearby. The stars stand out against the darkness because space itself isn't glowing. It is simply allowing their light to pass through uninterrupted. Every star you see is the end of an extraordinary journey. Its light has crossed the silent darkness of space for years, or even millions of years, before reaching your eyes, reminding us that the universe isn't empty of light. It's filled with invisible travelers, racing through the darkness until something, somewhere finally gives them meaning. At first glance, the darkness of space feels almost unsettling. It makes the universe seem cold, empty, and lifeless. But now we know that's only an illusion. Space isn't dark because light is missing. It's dark because the vacuum has almost nothing to reveal the light passing through it. Right now, countless photons are racing across the solar system. Others are crossing entire galaxies. Some began their journey billions of years ago, long before Earth even existed. They move silently through the darkness, carrying stories from distant stars, exploding supernovas and galaxies so far away that their light is only reaching us today. The universe isn't an empty void. It's a vast ocean filled with invisible light, constantly traveling in every direction. The darkness we see isn't the absence of light. It's the invisible stage on which light performs its endless journey. Without that darkness, we wouldn't be able to admire the stars. We wouldn't see distant galaxies standing out against the black sky. We wouldn't witness the glowing rings of Saturn, the blue oceans of Earth, or the brilliant clouds of distant nebulae. Ironically, it is the darkness itself that allows the beauty of the universe to exist. The next time you look up at the night sky, remember this: you're not staring into an empty void. You're looking through an ocean of invisible light, where every star is sending ancient messages across unimaginable distances, waiting for someone to receive them. Sometimes the greatest wonders in the universe aren't the things we can see. They're the things surrounding us that remain completely invisible. If this journey changed the way you see the night sky, let us know in the comments. What space mystery should we explore next? And if you're fascinated by the hidden science behind our universe, subscribe to PointView and join us as we uncover the extraordinary stories hidden in the cosmos, one question at a time.